Let's try a few questions, solving problems question. If you look at this question, which is given is 1200 Newton, then the volume, and the question wants the volume. Okay. We learned that when an object is floating, okay, the upward force is equal to the value of downward force. So the upward force is Fb, buoyant force, and downward force is weight. Okay, so we know that concept, and then we apply to the formula. Okay, Fb is equal to the weight of water displaced. Fb is equals to rho Vg, and rho Vg equals to what's given, 1200 Newton. And then we want V, therefore V equals to 1200 Newton over density and G, gravitational acceleration. So we substitute the values of density, 1000 kg per meter cubic times 10 to the power 10 Newton per kg. So we cancel out a few things, and that leaves us with the answer, which is 0.12 meter cubic. So number 15, the answer is A. Good. Okay. So many of you got it right. Okay. Okay, this is another example question, SPM question. Okay, but I want you to do this on your own. Okay. But look at part, okay, this is part A, and then I want you to look at part B. Okay, diagram 11.2 shows a boat, okay, without load, and then a diagram with loads. Okay, the weight of a boat without load is 15,000 Newton, and the boat is then loaded. We have the weight here, and then we have the volume, which is 5 meter cubic. Okay, and we give this one sign W and L, which is no load, and V1, VI, V immersed portion. Okay, calculate the buoyant force exerted to the boat. So what's the buoyant force? Okay, we apply the same concept. Okay, what do we have? Do we have any formula for buoyant force? Okay, that's right. Okay, then Fb equals to rho Vg, rho Gv, and we substitute the values. Okay, so this is a straightforward question. Okay, we just substitute the values. Okay, and V as 5 meter cubic. So this gives okay, and use calculator, 220 times 10 times 5. Okay. This is 51,000 Newton. That is right. Okay, good. Okay, I'm sure many of you got this right. Okay, and we can also write this in 5.1 times 10 to the power 4 Newton. So this is the answer in standard form. Okay, let's look at question number 2. What's the maximum weight of the boxes? What W max equals to what? Okay, we can recall, okay, this is a floating object. Okay, for floating object, it is in equilibrium. So upward force is equal to the downward force. Okay, what are the upward force and what are the downward forces? Okay. So let's label them. Upward force. How many upward force? Okay, good. Only one. Okay, that is FB, buoyant force. Okay, we label here. Okay, when there is no load, so the only downward force is weight. Okay, which is weight, no load, WL. Okay, but when there are loads, the downward forces are weight of boat and weight of load. Now we transfer these informations to the equations. Okay, so it says that weight of water displaced or weight of object, floating object, is equals to the buoyant force. So this is the formula that we get from the problems. And then now we substitute the values. Okay, WL is the weight of load. Sorry, let's write it according to what we have written there. So WL is the weight of load that we want to know. How much is the load? So we leave it as WL. And we know WB, which is 15,000 Newton. So FB, here we write the answers that we got previously, which is 51,000. So we rearrange the formula. Hence, WL equals to 51,000 minus 15,000, which is 36,000 Newton. Okay, right. So, yay, ramai yang betul. So that's the answer. So you can try on your own these questions. Then you can mark the question. Okay, so this is 1 mark, 2 marks, marks 3, 4, and 5. Okay, so you get 5 marks for this one. Okay, try on your own.